Okay, so today we're going to be talking about conics. So conic is if you took a cone and sliced it kind of different ways. I'll try to show that. So let me show you my Inspire here. So if you cut a cone exactly level with the ground, I guess, it would form a circle. The cross section there would. If you cut it kind of at an angle there, it would form an ellipse, kind of an elongated circle. If you cut it at a diagonal where it does not cut through, see that before it kind of, let me see, I cut through really nicely. It doesn't cut through the bottom of the cone. If you cut it so you do go through the bottom of the cone, it actually forms a parabola, the cross section does. And the other thing it forms, if you have two cones on top of each other and you cut it straight up and down, that forms a hyperbola, which is kind of those brown lines right there and there. So there are four types of conics: hyperbolas, parabolas, ellipses, and circles. So that's really this chapter. We're talking about those four types of conic. We're starting with parabolas. You've already done circles, I think, but this is a little different look at parabolas. So to understand this a little bit more, we're going to look at parabolas from this length. So we're talking about how you form a parabola, not just how you graph it like we've graphed in the past, but the definition of a parabola. So it's this blue line is the parabola, this whole thing there. But inside of that parabola is a focus point. And so that focus point is equidistant from, like if I measured to that point, it's 5.56 units, right? And there's a line, a dotted line called the directrix that's also equidistant to that point. So every point on this parabola, if I were to move this focus point or something, it changes. You see now every point in that graph is 6.56 away from the focus and the directrix, or at least that point is, I should say, at every point of the graph. Another way of looking at this, well, we'll get to that in just a second. So a parabola, this is the official definition, go and write it down. Set of all the points are equidistant from the fixed point F, called the focus, and the line L, called the directrix. And so it's going to look exactly like we just said. Don't draw this yet in your notes. We will learn more about this, but I do want you to know this concept. We'll talk about it again on the next page. You don't have to write it down yet. But the distance from the vertex of the parabola to the focus is called C. It's a distance of C. And the distance from the vertex to the directrix, a straight line, 90 degree, that's a 90 degree angle, is also a distance of C. So they're equidistant, no matter what point. That point could be the vertex, or it could be a point out here. Again, if you measure this distance and this distance, it's going to be exactly equal to any point on that parabola, but even the vertexes. So that's really helpful to know the value there of C. 2.1. So let's look at that. So you can see the closer the focus is to the vertex, now it's only 1 unit away, the kind of skinnier this parabola gets. If I kind of move it up, now it's 5 units away, it's a much wider parabola. If I move it down below the focus, is down below the vertex, it's going to be opening downwards instead of upwards. So it always opens in the direction of the focus. That's really kind of helpful, actually. And the focal diameter is 4 times the value of C. So go ahead and write that in your notes. So focal diameter is equal to 4C, or the absolute value of 4C, I should probably say. Focal diameter is a distance, so it's always positive, but it's just 4 times whatever C is. Again, C is the distance from the vertex to the focus. And page 3.1, we'll put this all together in just a minute. Page 3.1, you can see that like this is an A value of 1/8, and so it's pretty wide, 1/4. If it gets the smaller that number is, the wider it probably gets. The bigger that number is, like 1/4, is actually it's a little bit skinnier. If you can see that focus could be opening to the left, the parabola could be open to the left, so that would make the whole thing. And again, it's always equidistant. You can see the directrix is 2 units away and the point is 2 units away. So you can have x equals parabolas. Those are x equals parabolas. They open right and left. Y equals, where they open up or down. Again, x equals open left or right. When it's positive, opening to the right, that's an a value that's positive there for 1/8 is a positive number. Now 1/8 is also a positive number. Opens up and to the right are positive directions. You can see that if I'm opening down or to the left, those are negative directions as far as the parabola is concerned. Okay, so now get out your notes. I will want you to take good notes on this because I want you to use these notes on the test. So unless you use like a note card, pack as much stuff on there as you want as far as formulas go. And so this will be a really nice set of formulas to go. These are formulas for when the vertex is at 0, 0. So I'm going to clarify that. So if the vertex is at 0, 0, all these formulas we're about to write down apply. So this one applies. In fact, we can shorten this because h and k are 0, 0. We can say this formula is just y equals ax squared. That's a much simpler formula, right? Because for these formulas we're doing on this paper, we'll get to the shifted around formulas in a little while. But right now, this first section, we're kind of baby stepping you into conics. And so with every problem, the vertex is always at the origin here. And again, this point is called F for the focus point. And this line down here is called the directrix line, directrix. And every point on that parabola is equidistant to the focus and the directrix line, measured at a 90-degree angle. And so this point here is the focus is at 0, c. So that's going to be our ordered pair here, 0, c. Because remember we said the distance there from the focus to the vertex is called c. If c is positive, if it's opening up like this, c could be negative. If it's parabola is opening down, c would be a negative number, but the focus still would be 0, c. So that distance there, c, again, this distance here is a distance of c, even if c was negative. In this case, c is positive because it's opening up. The directrix line is the equation. It's a horizontal line for this type of graph. So y equals negative c. Because we're going in the opposite direction, we're opening, so it's a y equals line, so that dotted line right there is the directrix line. A is actually a really important formula. So A is that coefficient in front of x squared, right? So that number right there, if you have A, you can figure out C, which is really helpful. Or if you have C, you can figure out A using this formula. So oftentimes in a problem, you'll be given either A or C, and you just have to kind of fill it in. Focal diameter is equal to absolute value 4c. We mentioned that. 4c, absolute value 4c. So this distance is 2 times c to that point. And the other endpoint of the focal diameter is this distance, and this distance is also 2c. So 2c plus 2c is 4c. So that total distance from, so the focal diameter is really like this, from that point to that point is the focal diameter. So that's a distance of 4c right there. So that's just how you find it. It's always twice as much. So it's kind of helpful if you know c, you can go 2c in that each direction. Now you have a point, and then you can graph your parabola. So we're actually going to use c to graph a parabola. It's a different way of graphing a parabola. We've graphed a parabola a number of different ways already this year. So it's just a new way of doing it. Let's use those formulas. This is definitely a y equals parabola. It may not be obvious to you at first, but if you solve it for the variable to the first power, in this case, y, so we get y equals negative 1/8 x squared. So that value right there is our a value. So a equals negative 1/8. Right away, I know this parabola is kind of opening down because a is negative, so y equals parabola. So instead of y equals x squared, which opens up, it's a negative number. So I know this parabola is opening down. Find the focus and directrix of the parabola and sketch its graph. So let me kind of get some graph paper out here. Okay. Oops. Okay, so let's go ahead and sketch this graph. Okay, so we've got find the focus and directrix. So the directrix, so we know A is negative 1/8, and we know that You can use this formula either way. C equals 1 over, let's look back at that. A equals 1 over 4C. So A equals 1 over 4C. I like to have both versions of the formula. Or C equals 1 over 4A. I want to solve for C, so I'm going to plug into this one. But you could, those formulas are pretty much interchangeable. So C equals 1 over 4 times negative 1/8 is my A, so negative 1/8. So this is 1 over, that's negative 4H, which is negative 1/2. So C equals negative 2. So my equation for my directrix, if you remember, is you can do this two different ways. So one way of doing this is to go, okay, C is negative 2, so I know 0 comma C, like that's my focus point. That's got to be my vertex, because all these are under the assumption in this first chapter that the vertex point is at 0, 0. And so this distance is C, 2 units down. And so really I know where my directrix is going to be. It's going to be right here. But if you don't see that, you can, oh, it's the same distance as C is negative 2. But this equation would be y equals negative 2. If you don't see that, the formula is y equals negative C. And so this would be y equals negative 2, which is positive 2, which is y equals positive 2 there. So that's the equation of that one. This focus point is at 0 comma negative 2, which is, again, according to the formula, the focus point is at 0 comma C. C is negative 2, right? So this would be 0 comma negative 2. So you can get that focus point as well. Okay, so now let's use our, it says focal diameter, sorry, is equal to 1 over the absolute value 4C. So absolute value 4 times negative 2. So that equals negative or positive 1/8. It's a positive number every time. So I'm going to go, no. Let me just redo that focal diameter a little bit here. I knew something was wrong. It's like, wait a second. Okay, so the formula for focal diameter, if you wrote it down a few minutes ago, is the absolute value of 4C. So that is the absolute value of 4 times negative 2, which is positive 8. Absolute value of negative 8 is positive 8. So we go 8 units, or half of that in each way. Because remember, the focal diameter, if it's set up kind of this way, here's the focus point. So here's the endpoints of those. It's 2C in each direction, right? It's 2C from there to there. It's 2C from there to there. So 4C is 8. So I'm going to go 4 units in each direction. So starting at the focus, we go 1, 2, 3, 4 points to the right. And 1, 2, 3, 2C, or 4 points to the left. And so now I have enough points to graph my parabola. I've got the vertex at 0, 0, goes through that point, goes through that point. Oops, sorry. And you've got, that's enough points. I want to see that point. The end points of the focal diameter is what I want you to graph. And the 0, 0, of course, is the vertex. Okay. So you do need graph paper for tonight's homework, by the way. These are the formulas for, this is a kind of a sideways ellipse or an x equals ellipse. Again, for all of our examples, we're going to say the vertex is at 0, 0, right? So this is 0, this is 0. So our formula really is, for this type, x equals a times y squared. Anytime it's an x equals graph instead of a y equals a times x squared, it's going to be opening sideways. So it's still a parabola, but it kind of opens in a sideways direction. This is the vertex point. Still a distance of, from there to there is C. C is definitely positive in this graph because it's opening to the right. These are the endpoints of that focal diameter that we use to graph it. So this formula is exactly the same for both. Focus point now is at, this is C comma 0. So even C could be negative, but it's positive in this case. So C comma 0 is the formula for that. Directrix is an x equals line, so x equals opposite of C instead of y equals opposite of C. And the focal diameter is absolute value 4C. That's just really the same that we had before. Find the focus and directrix of the parabola and sketch its graph. First, put it in the right form. So I don't like this. I'm going to move the 1/2 x over to the right by adding it. So I get y squared equals positive 1/2 x. I'm going to multiply both sides by 2. So I get this cancels. So I get x equals 2y squared. I really have to get it kind of in that form where I solve for the variable that's to the first power, which was the x. That's how I knew to solve for that one, and not the y. So now I know I have a parabola. It's a sideways parabola. A is positive. A is equal to 2, in case you didn't see that. A equals 2. C equals, just use that equation, C equals 1 over 4c, 4a. So this would be 1 over 4 times 2, which is 1/8. So C equals 1/8. So this is going to be a little tougher to graph. I'm going to try to do this. So let me pull over some graph paper here. Okay, so let's try to, I'll try to not use the formulas because typically students do better when they don't use the formulas a whole lot. I know that sounds funny, but here's what I mean. So vertex is 0, 0. For every problem in your homework, it's a 0, 0. This is an x equals parabola, which means this parabola is going to be opening to the right or left. And I think it's definitely going to be opening to the right because C is a positive number, A is a positive number. So when you see A is positive or C is positive, you go, okay, it's opening to the right or up. In this case, to the right because it's an x equals parabola. So I'm going to go 1/8 to the right. I guess it'd be like right about here. That's at the point 1/8, 0. Now, because my focus point is at 1/8, 0, my directrix has to be the same distance away. So it's going to be x equals negative 1/8. And again, you really could have just used the formulas for this. The formula is x equals the opposite of c. You knew that c is 1/8, so it would be x equals negative 1/8, which is what we got. The focus point is always just 0, oh no, for this type of graph, it's c, 0, isn't it? And so the focus point should be at 1/8 because that's what c is, 0, which that's where it's at. So you've got that. And so the thing we need now is the focal diameter. So which is equal to the absolute value of 4c. So the absolute value of 4 times 1/8, 4 times 1/8 is equal to 4/8, which is 1/2. So focal diameter is 1/2. So that means I go half of a half, which is a fourth. I go a fourth in each direction. So I'm going kind of up a fourth and down a fourth here. So it's like a fourth and a fourth, and that's enough to draw my graph there because I know it goes through the origin. And it goes through those 2 points that are 1/4 of a distance away from that focus going up and down. What do you know about the value of A? So this is, by the way, this is definitely an x equals graph. So x equals ay squared because it's opening left or right. It's opening left, so A is definitely negative. So A is going to be negative in that case. This is a y equals graph, so y equals a x squared. And A is definitely equal to a positive number because it is opening up. This is also a y equals ax squared type of graph because it's opening up or down. A is definitely equal to a negative number. And this is an x equals a y squared, opening to the right or left. It is opening to the right, so A is definitely equal to a positive number. Last thing of the lesson is completing the square. So as we've done a couple different versions of this. This is just a slightly different version. So you want to always move the constant over to the other side by subtracting it in this case. So I get y minus 2 equals x squared plus 4x plus blank. So what you want to do here is you want to do half that middle term squared. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. And so I get y plus 2 over here. This should factor perfectly. It's x plus 2 squared. And last step, move the constant over. So you get y equals x plus 2 squared minus 2.